What you're looking at right now, we call the Osci-Laser. My name is Ethan Rowland.
And I'm Matt Corrigan.
And what you're seeing right now shouldn't be possible. Light shouldn't be able to have discontinuities like that. But taking advantage of something called the rolling shutter effect, we were able to make it happen. I want you to note that this effect is 100% in camera, meaning that it happens due to the interaction between the laser and the recording of the camera itself. Importantly, there is zero digital post-processing to this actual effect. You are seeing this video as we have captured it on our camera. This instrument works by having an output, which is the column of light, having an input, which is an ultrasonic sensor that detects our distance from the base of the instrument, and also outputting varying signals to modulate the sound produced by the Werkstatt. Matt is going to demonstrate the operation of this instrument right now.
This, of course, can be used to modulate any effect, such as the filter. Now, because we can measure the distance of the user from the laser itself, and we can create arbitrary discontinuities in that laser, we can actually sequence an arpeggiator and then play it back. And we can actually visualize the notes that are being played with breaks in the beam. Now, Ethan will go ahead and demonstrate that now. We actually have a number of plans for the future for this project. We didn't initially realize the difficulties of driving a laser diode, and the commercially available diode drivers within our budget had a poor frequency response, so they couldn't actually switch with a square wave on and off. And so we would like to drive with a more powerful laser in the future.
Yeah, so this project is really interesting from a lot of different perspectives. Matt's an electrical engineer, and I'm a computer scientist, so it really kind of used a lot of both of our skills. Just to go into a little bit of how the rolling shutter effect works technically, more or less, we have a laser, and from our eyes, it's on the entire time, but it's just flickering. And we time up the time where a camera reads a particular row within an image with whether or not that laser is on. And by timing whether or not a laser is on while the row is being read into memory for the camera, we're able to arbitrarily set pixels on that camera, either on or off. It's a very tricky and very precise project, and that required a lot of low-level programming on the Arduino, on microcontrollers, and that was a really cool experience for me.
We had a really great time participating in the Moog Hackathon, and we hope you enjoyed our video, and we're looking forward to seeing everyone else's videos as well.